Hi, today we're doing problem 5-8. So, first part asks us, determine the angular velocity of the bar immediately after the collision. So we're going to use conservation of energy, so the kinetic energy initially is going to be this equals the potential energy that's created once the bar goes up, as it swings up. Now, 1/2 ml squared 3, it gives us this, times omega squared equals, and now, it tells you that it goes 90 degrees upwards. So, you also have to realize that the center of the mass is halfway, like in the middle of this rod. So, using that information, I'm going to plug it in. So, mass is 3, it's given. G is 10, it's also given. And then the height is going to be 1/2 divided by 2. So you're going to do some basic arithmetic, and you have to remember that M and L are both given. Then you should come out with 5 equals 5, omega equals 5 radians per second. That is your answer. Now, part B. It asks us to determine the speed v of the 1 kilogram object immediately after the collision. So, once again, conservation of energy. So, before the collision, it's going to be 1/2 mv0 squared. After it, mvf squared plus the kinetic energy given to the rod. Now, we have all of these given. The ball is only 1 kilogram. The velocity is 10, this is given. You plug the rest in, except VF, which is what you solve for. And, you have all of this, it tells you what it is, and you know all the variables. So, you basically do math, and then you'll come out 5 equals 8 meters per second. Determine the magnitude of the angular momentum of the object about the pivot just before the collision. So, the equation that you use, L equals R cross P, this is on your equation sheet, and since P equals mv, and also you have to realize, for collision, V is completely perpendicular to the axis of the center of the rotation, which is up here. So you don't have to. So this cross product is it's full. So it's just equals mvr, and you know m of the ball, you know its velocity, you know its radius, which is the length of the rod. And that gives you 12, and the units are kilogram meters squared per second. Problem D, last part, determine the angle at which it comes off after the collision. So we're just going to do conservation of angular momentum. So we already got the initials 12, right, before collision. Final is going to be mvr cosine theta. And if you're wondering why, it's because cosine times the velocity, so we only want the horizontal component since that's what's actually perpendicular to the radius, right? And so we do cosine theta times the velocity, so it'll give us the horizontal component. So we have this, and then you also have to remember that the part of the momentum's transferred to the rod, and this is the momentum of the rod. And then you know all of these variables. Right, and then do conservation of momentum. You can't do conservation of kinetic energy because it's not conserved, because it's around a pivot, and the pivot introduces external energy. It's not, the pivot isn't part of the system. So, but momentum is always conserved. So you do 12 equals, you compute this, so it comes out to 9.6 cosine theta equals 7. That cosine theta equals 0.5 after you clean that up, and then obviously theta is going to be 60 degrees, and that is your answer.